Okay, guys, so these are the four problems that I said I was going to do from section 4.3. So you should have, I'm sorry, section 4.2, my bad. You should have your textbook open next to you and looking at these problems. All right, so first off, number 18. Number 18 asks us to A, show that the function f satisfies the hypotheses of the mean value theorem on a given interval. So A, does f of x equal ln of x minus 1 satisfy the mean value theorem? So if we remember, the mean value theorem says that f has to be continuous. Is f sorry, I forgot to include that this is the function that is given in number 18, and then they give the interval 2, 4. Okay, I forgot to put that in there. So let's just recall. I'm going to put down, let me get the mean value theorem notes. So let's remember what the mean value theorem says. It says if y of f of x is continuous at every point of the closed interval, a, b, and differentiable at every point of its interior, a and b, that means f of a and f of b exists, then there is at least one point C in A and B which satisfies the mean value theorem. So to check for part A is just saying, is f continuous on the interval 2 to 4? Now we're going to say yes. The reason we know that is because f of 4 is ln of 3, which is a number, okay, and then f of 2 is differentiable because f of 2 is ln of 1. So if you're questioning where, how I'm answering this question, if you look at the example in the textbook on page 187, example 2, applying the mean value theorem, or example 1, exploring the mean value theorem, it's a quick little definition that explains it, okay? So because this function is not a division and it doesn't have a radical, that means it is going to be continuous and there really isn't any undefined points here, okay? So then part B says, all right, now that you've concluded that this does satisfy the mean value theorem, part B in this problem says, find the value of C. So find the value of C. So since part A, yes, it does, the mean value theorem does work, then we know that f prime of C will equal f of B minus f of A over B minus A. So f prime of C is equal to f of 4 minus f of 2 over 4 minus 2. So f prime of C is equal to f of 4, if you remember, is ln of 3, minus f of 2 is ln of 1, divided by 2. Now I know that ln of 1 is 0, so f prime of C is equal to ln of 3 divided by 2. And this is a number, okay? If we were to plug this into the calculator and calculate, so ln of 3 divided by 2 is 0.5493, 0.549306. But I'm just going to keep it like this, pretending that I don't have a calculator to work with right now. So now I know that f prime of c is equal to this. So what I have to do is figure out what is the derivative of the function. And just to stay in the same sense, because it is asking for c and we are calling c the point where the tangent line is, basically all I'm going to do is I'm going to call this function now f of c. So f of c here is just ln of x minus 1. So what is the derivative of f of c? Okay, it's ln of something, so it's 1 over that something, times the derivative of this, which is just 1. And we now know that this equals ln of 3 divided by 2, which is just a number. Okay, this is a constant. So now, oh, I forgot to change that to a c, but it doesn't really matter. Okay, as long as you can identify that the x is a c and c is an x, you're fine. So now I want to get that out of the denominator. So I'm going to go 1, because I'm going to multiply both sides by the denominator, c minus 1. So 1 equals ln of 3 over 2 times c minus 1. Now remember, this is one number. So to get c by itself, I'm going to divide both sides by ln of 3 over 2. Divide by ln of 3 over 2. Flip the guy and multiply. You end up with 2 over ln of 3 equals c minus 1. Add 1 to both sides. So 2 ln of 3 divided by 2 plus 1 equals c. Now, would this have been easier if I changed that to a decimal? Definitely. But let's pretend we don't have a calculator. So, what is c? It's 1 plus ln of 3 over 2, which, if you put this in the calculator, which you don't have to, is approximately 2.82. So both of these would have been the correct answer. All right. And then you can try number 17, you can try number 15 in that little section to test if you understood what we just did. All right, the next problem. Number 20. So number 20 says, find the secant line equation of f of x equals the square root of x minus 1 on the interval 1 to 3. So remember, the secant line is f of, or the slope of the secant line is f of b minus f of a over b minus a. So the slope is f of 3 minus f of 1 over 3 minus 1. So f of 3 is the square root of 3 minus 2, which is square root of 2, minus f of 1, 1 minus 1 is 0, so the square root of 0 is 0, divided by 3 minus 1, which is 2. So the slope of our secant line is square root of 2 over 2. So now I know my slope. I have an x that's on the secant line, which is, I'm going to pick 1. And then what's my y? So if x is 1, what was my y? It's right there, 0. So now that I have my y, my x, and my m, I can go ahead and plug them into the equation. So 0 equals the square root of 2 over 2 times 1 plus b. And we end up with negative square root of 2 over 2 equals b. So what's the equation? Y equals the slope, which is square root of 2 over 2, x minus square root of 2 over 2. So this is my secant line. Now part B says find the tangent line that is parallel to AB. Now, bear with me here because we can't really pick two, all right, to figure this out because we're not guaranteed. And I know I said that in class, but that was my mistake. We do have to use the mean value theorem to figure this out. And what the mean value theorem says is that the slope of the tangent line at that point C is equal to the slope of the secant line from A to B. And if you remember, we found the slope of the secant line. So I don't have to plug all this in over here. I already know what it equals, and it equals square root of 2 over 2. So if the derivative of the function equals this, the question is, where does it equal this? What is f of c? So here what we have to do is get the derivative of the function. So it's the chain rule, which you end up with 1 over 2 square root of x minus 1 equals square root of 2 times 2. And remember, I don't need to change this to a c, but if it makes you feel better, you can, okay? Now I'm going to multiply both sides by 2 to solve for c, so I'm working on solving for c, which that ends up canceling both 2's out. So now we have 1 over square root of c minus 1 equals square root of 2. Multiply both sides by square root of c minus 1 to get it out of the denominator. So now that's gone. So 1 equals square root of 2. And now I can technically put these together in the same exact square root, but what did I just do? It's fine. Okay, so I can put these in the same exact square root, and then what do I end up with? And you know what? I don't even know why. Okay. So then I have square root of 2 and square root of c minus 1. I want to get this stuff by itself. And you'll see kind of the stuff that I'm doing, you don't really have to do. I could have just squared the whole entire thing and gotten rid of them, but I don't know why. This just makes me feel a little bit better to get just the c stuff by itself. So 1 over square root of 2 equals square root of c minus 1. And now I can square both sides. So 1 squared is 1 over 2 equals c minus 1 because that cancels that out. And remember, this cancels this out. Add 1, so 1/2 plus 1 is going to be 3/2. So 3/2 is c. Or we can also say that 3/2 is x. So now I know my x is 3/2. So my y is what? If I plug in 3/2 back into the original equation, I know that my y, when x is 3/2, my y is going to be 1 over the square root of 2, or 3/2 minus 1, which is a half. So it's the square root of 1 over 2. Which, remember, you can just write it as 1 over the square root of 2 because the square root of 1 is just 1. And then I have my m. Because the line is parallel, I know that the slopes for these two lines are going to be the same. So I have my m, square root of 2 over 2. So I plug it in into y equals mx plus b. So 1 over square root of 2 equals square root of 2 over 2 times 3 halves plus b. Do the math, right? Multiply these two together and then subtract. And you end up with, if you use a calculator, you're going to end up with 0.354. If you don't use a calculator, you're going to end up with 1 over 2 square root of 2 equals b. So my equation is y equals square root of 2 over 2 x plus 1 over 2 square root of 2. All right. Next problem. Promise it's easier. 27. So 27 says, find all possible functions. So find f's for, so find the f of x basically, for the given derivative. So number 27 gives us f of x, or f prime of x, equals 3x squared minus 2x plus 1. So basically, the antiderivative is, there's two ways to look at this. You know that you subtracted 1 to get 2, or just take this and replace that 2. So the function is actually x cubed minus x squared plus this 1 technically is going to be, right now there's x is 0, so that's going to go over there, plus x. And then of course don't forget your plus c. And then you can double check yourself because you know that x cubed, what is the derivative? 3x squared. What's the derivative here? 2x. What's the derivative here? 1. And what's the derivative of this? 0. Alright, number 43. I should probably do this on a separate sheet actually. Alright, so number 43 is like the story problem that we did. It's actually a little bit easier than the one that we did in class, but it's the same exact concept. So number 43 tells us that on the moon, the acceleration due to gravity, so the acceleration on the moon is 1.6 meters per second squared. So part A says, if the rock is dropped into the crevice, how fast will it be going just before it hits the bottom 30 seconds later? So here's the crevice of a moon. Let's say you're dropping the ball. No, should be right here. So we're not really moving it. So you're dropping the ball. It's taking 30 seconds to hit the bottom. So in this problem, we know time, right? But we don't know the distance, which is different. It's a little bit different than the problem we had before. So how fast is it going? That means we need to know the velocity. So the velocity is the antiderivative of acceleration. So this is just going to be 1.6 t plus c. Now the question is, what is c? And the only way that we can figure out c is by using something that we know. And what we know right now is that at 0 seconds, how fast was the ball going? Which means before the ball was dropped, how fast, before the ball started falling, how fast was it going? 0 meters per second. So if v of 0 is 0, so that means 1.6 times 0 plus c is 0. So what is c when you solve this problem? So 1.6 times 0 is 0, 0 plus c. c is 0. So in this problem, we don't have to worry about c. Now, the velocity section in here is pretty easy. How fast was it going after 30 seconds? We have the time, so we don't need to figure out the distance right now because this part is just asking about how fast was it going after 30 seconds. So that means v of 30 is 1.6 times 30. Plug that in your calculator and you get 438 meters per second. So at 30 seconds, the ball on the moon was going 48 meters per second. Now part B, it says how far below the point of release is the bottom of the crevice. So this is the distance. And if you remember, the distance function is s of t. And s of t is the antiderivative of velocity. So what is the antiderivative of 1.6t? Take a second. It is 0.8 t squared plus d. And you can double check. How did I know that? I basically knew that there was a 2 here and it came down. So how did this get doubled? Because it was 0.8. So 2 times 0.8 gives us 1.6 t. So here the question is, what is d? All I know is that at 0 seconds, how far did the ball travel, or the rock? 0. So if s of 0 is 0, then d is going to be 0. So again here, we don't have to worry about d, the constant. So that is our s of t function. Now they told us at the beginning that the ball took 30 seconds to drop to the bottom, right? So guess what? Again, we know time. We know that it takes 30 seconds for the ball to hit the bottom. So that means the bottom is 30 seconds later. So what is the distance to the bottom? It takes 30 seconds, so it's just 0.8 times 30 squared. And that is going to be 720 meters. So part A and part B, very similar to our story problem in class, but a little bit easier because they actually gave us time this time rather than the distance. So we didn't have to use this to find this, okay? It was a little bit simpler. Now part C, and I'm going to do a little task with you if you really want to study hard for this test. If you want me to grade it and to check it or look at it, do this problem. I'm going to give you the answers. I mean, I really don't have to because you have the solutions manual. Now the only difference in this problem is v of t, because part C says instead of being released from the rest, the rock is thrown into the crevice from the same point with a downward velocity of 4 meters per second. So if v of t is 1.6 t plus c, here c is not going to be 0 because v of 0 is 4. Because before the ball starts actually moving, it's given a velocity of 4 meters per second. So what that means is that c is 4. So the velocity function is 1.6 t plus 4. Okay? Which means that it does not take it 30 seconds to reach the bottom, right? It's going to reach the bottom a little bit quicker. So here, we don't know time. But because of part B, we do know the distance, which is 720. So we're going to use the distance to find the time, and then we are able to figure out the velocity. So this part C, is very similar to our notes section. Now I'm going to stop the video here. I'm going to let you guys kind of figure this one out. There should be a video being uploaded of more problems from Al Hussein by Sunday night. If it's not, it's fine. I mean, you don't really need it, but if it is, it will be helpful. Please email me if you have any questions.